yeah, I want to tell you about Pretty Easy Privacy, which you might have guessed is coming from Pretty Good Privacy, PGP. So who knows about PGP or GPG? Okay, that's most of you. Who doesn't know anything about it? Okay, just like 1, 2. Okay, who's using PGP or GPG? Okay, that's much less. And who's using it daily? Okay, there's 2 left. That's the problem we want to solve. So it's, for the ones who don't know at all, it's about encryption. I have this intro stuff there, but I think I want to skip it. I just go briefly through it because most of you are apparently aware about this. So this is how encryption works generally, and PGP, GPG is a way for asymmetric encryption. And I just want to briefly go into this. The 4 rules of thumb. If it's not open source, don't use it when it's about encryption. The older something is, the more likely it is secure. But then also keep an eye on the recent happenings, because if something is very old and not unbroken, it can be like broken every day. Maybe you remember that famous article, Telegram stand back, we have math PhDs. Which is 5 years back from now, but then they have invented some new crypto, and it broke pretty soon. And then also, always very important, where does it come from? Who is developing it? Like, who's having an interest of having this, whatever it is, crypto technology on the market? And then another note on OpenPGP, there is Sequoia. That's a project we also support as the PEP Foundation. Those are developers formerly working on GNU-PG to create a new opinionated OpenPGP implementation. So this is all quotes from their website. They call it a cool OpenPGP library, which should not dictate how it is used. Keys are automatically kept up to date, because that's one of the problems we have right now. The whole key management is a huge issue. Also, key rotation is there, and it's written in Rust. So it has a modern code base and has lots of flaws, like deleted, which other implementations still have. And it comes with a C API. So, but now going into the actual talk. So I first give you guys an intro. Then I'll explain the technology for mass encryption, which is a rather long chapter. Then the general concept of PEP, which I skipped through, very brief, I guess. And then we'll see how much time is left for the technology for mass anonymization, the metadata protection via GNUnet. If not, I'll do that as a lightning talk tonight, then, like as a single chapter. Also, you can interrupt me with questions anytime if you want to. So yeah, coming to like what is PEP? It's a software for various platforms to easily use existing crypto tools like GNU-PG. So it's pretty easy. Like that's at least what we're trying to. It's designed to encrypt all digital written communication with the starting point of email. So far the software only encrypts email, but as you learn in the tech chapter, the concept, the whole architecture is made that it can encrypt any kind of transport protocol which we can think of. It encrypts automatically with whatever most privacy-enhancing crypto standard available. So it follows the opportunistic approach here. So rather take any encryption or like the one you just can get hands on the easiest. And all end-user software must be hassle-free and zero-touch. So we're trying to have this pretty easy. Also important to say, what is PEP not? It's not yet another crypto tool with a closed user base, because we do have some easy-to-use crypto tools out there, but then it's always those tools where you have to convince all your friends to use the same tool. Like, oh, this is great, it works nice, but then I can only talk to people who are using the same thing. So PEP is an approach to be compatible with everything that exists out there. also, it's not a platform provider, also not centralized. I mean, central instances are always a problem because they can be attacked. And they have like a central instance. I mean, it can always be attacked. But if you attack a central instance, your result is much bigger than if you just attack like a single person because you have end-to-end encryption. And also, we're not implementing any own crypto and not replacing any existing crypto tool per se. That's pretty important because we cannot have monopoly in any of these things. We need to have a heterogeneous environment to be safe. So we definitely don't want to replace existing crypto tools. We, on the other hand side, want to support other crypto tools as well. And what we want to do is to make the use of those existing crypto easy. So the tech people shall still use their like very sophisticated setups, like using MUT, having GPG directly in email, or I recently met someone who's using email on Emacs actually, but also using GPG on there. So this shall still be there, but you cannot expect this from the people out there, because at the moment they don't use any crypto, and this is what we need to change. Also, it's not just an email encryption tool. That's just the beginning. Okay, then who is PEP? I just told you that it's important to look who is those people. We see ourselves as cypherpunks, and we want to roll out mass encryption to optimize the costs of mass surveillance. We make the use of crypto pretty easy, so that the developer can just plug it into apps and that the user just uses it by default. So you might wonder what cypherpunks. Here are some quotes from the Cyberpunk Manifesto. I think I don't read it. It's like making the network safer, route to social political change using crypto. The middle part, I want to read it because I always find it important to understand this thing, especially like when you're in security conferences, it's not an issue everyone understands, but then often people are like, okay, privacy, but I don't have anything to hide, right? So what does it matter for me? What does it matter for my users? So just to make this distinction, a private matter is something one doesn't want the whole world to know, but a secret matter is something one doesn't want anybody to know. I think lots of things everyone has who, like, you might not have something which is secret, but you might have lots of things you don't want the whole world to know. Yeah, some more quotes from the Cyberpunk Manifesto. I think the lower part is important. Someone has to write software, and we're going to write it. So this is our motivation, or like where we're coming from. Then also a few notes about me. I'm actually from the humanities, so I studied anthropology, but also computer science. Also, I'm a craftsperson, so I learned to be a carpenter. SWA is a unique addressing in internet and web. If you want to know my legal name, you can check out the board members of those associations here, the Chaos Computer Club and Hackers Without Borders. You will only find one female name, which is mine then. Also, I'm involved into the crypto party movement, and I organized and founded various events all around the world. And yeah, that's my background. And now another piece of the motivation, the human rights. So everyone has the right to protection of the law against arbitrary interference with his privacy, family, home, or correspondence. So this is written down in the human rights, but then we know that nearly no law on the world, like governmental law, is actually protecting us here. So what we need to do is we need to use the law of mathematics. And that's what we're doing. Because we do have this problem that we do live in a world where everything that I say, everything that I do, everyone I talk to, every expression of creativity or love or friendship is recorded. That's the world we have right now. We knew it all. I mean, everyone who's into technology knew that this is the case. But now, since more than 5 years, we know it, like it's been proven. that everything gets collected, gets scanned, and it's even worse. It's not that only the governments are checking all the traffic for criminals, because, I mean, there's something okay with that, to look for criminals, to look for terrorists. But then we also have this problem. That's 2 pigs sitting in a barn. Isn't it great? We have to pay nothing for the barn. Oh yeah, and even the food is for free, right? So those pigs, they don't understand that if you're not paying for it, you're not the customer, you're the product being sold. So this is the world we are living right now. So yeah, the problem is online communication is visible like a postcard, and this world has mass surveillance. But there is a solution. There's encryption, there's anonymization. So what's the thing? I don't think it's really a solution. I mean, theoretically it is, but that stuff is there since decades, and it's still too hard to use. I mean, I just asked you guys, so it was 2 persons in the room who are using email encryption on a daily basis. Who's using anonymization, like Tor or something, on a daily basis? Yeah, that's another 2, 3, 4. So that's like, and Tor isn't even too complicated, right? At least if you use the Tor browser. So what we need is to have this as mass encryption. We need to have privacy by default for everyone out there, that they don't even realize what's the difference. Like we have it with HTTP and HTTPS. Since Snowden, HTTPS was spreading out very wide. A normal user out there doesn't even know the difference. They don't even see the difference. But that's not an issue, because now they're like safer in the web. And then we need mass anonymization, privacy by design. Okay, so PEP wants to do what the user would want to do. So we're coming from this, crypto party movement, for example. Lots of us have been taught to other people, GPG. I don't know how many 100 people I've taught GPG, especially in the year of Snowden. And I'm actually glad if there's like 5 still using it. So instead of writing how-tos and guides, we want to write user expectation into software and protocols to automatize all the steps a user would need to carry out. So to take away the crypto needs from the user view, like HTTPS I just explained. So to do that, like writing a protocol, we write an RFC. It's already written a year back or 1.5 years back. It's a so-called internet draft, which is the first step of writing an RFC. It's done with the ISOC Switzerland. It's on the general PEP principle, and you can check it out online. That's a zoom in of the abstract. I read out the underlined part. Building on already available security formats and message transports, pretty easy privacy describes protocols to automatize operations, key management, key discovery, private key handling, that have been seen to be the barrier to deployment of end-to-end secure interpersonal messaging. So that's what PEP is doing. And what does the user do? Writing messages, nothing else. So this is how that looks like. So here we have 2 PEP users. It can also be 1 PEP user and another just normal GPG user. So the first email goes unencrypted. So Alice writes to Bob an email which is unencrypted, but here the key is already attached because the key gets generated in this step. So the PEP user doesn't even get to know about keys or something. The PEP user just writes an email, and now Bob replies back, which is already encrypted because the key was attached. The software sees, oh, there's a key attached. So I reply encrypted and attach my key as well. So after this one handshake where we make trust on first use, we are in an encrypted channel already, and the person who's not into crypto can just like write emails, doesn't see any difference. But then as we're doing trust on first use, it's actually pretty important to also check fingerprints. We translate fingerprints into so-called trust words. So the usual thing, you need to call each other or something. I mean, establishing trust you can still only do between people. like persons need to trust each other. And then afterwards, machines can trust each other after persons said, yes, machines, please trust. So this is something we cannot automatize. So here again, another diagram. So the first email goes unencrypted, has the key attached. The second one already goes encrypted, also has the key attached. And now we're in an encrypted channel. But then we do the verification, and now we're in a secure and verified, trusted channel. Okay. Any questions till now? I mean, that was anyway just an intro. Okay, so I go into the tech chapter. So there is the architecture, which consists from engine, adapter, applications. Then I also explain the organizational form, because that's also quite a part of our tech, which also makes it easier to explain our repositories. And then last, all the developing platforms we're working on. So the architecture, as said, there are applications on top, there is adapters in the middle, and there is an engine on the bottom. I go into more detail of each of those components, but there you already get an idea. So the engine does the crypto, the adapter connects to the app. For example, for Outlook, you need a COM server adapter to plug in Pap engine, or for Enigmail, which is the Thunderbird plugin, you need a JSON adapter to plug in the engine. Here are more examples. For Android, you have a JNI adapter. For iOS, there's an Objective-C adapter, and so on and so forth. So you have adapters for nearly every environment, which is, let's say, widely used. So what is the engine? The engine drives several crypto standards on different digital channels, which means message transport protocols. At the moment, only email, but the idea is mass encryption, so it's not only about email. It's written in C99. It has, I think, meanwhile, a bit more than 10,000 lines of code and gets regular code audits. I mean, regular, it got one so far, but we're at the very beginning and we have a concept of having regular code audits, so far it got one, and then there are more to come. It's not meant to be used in the application code directly. And as a developer, you can just plug and play the engine. Also, again, plug and play. Our documentation is not very well yet, but again, that's the idea. So if you want to plug it right now, you might be a little bit disappointed that it's not that much plug and play as I claim here, but that's like the usual thing of documentation. I think you all know what I'm talking about. So that means as a developer, you don't have to maintain any crypto. But you might be, okay, what? But then I have to trust you. Yes, sure, that's the idea. It's all open source, it's all free software, it's been code audited, and you can check on it. And also, you can also still implement your own crypto. As I said, we don't want to replace anything. We just want to make it easier, not only for the users, but also for the developers to actually roll out more encryption in this world. So the engine takes care of the messaging function, the crypto tech services, so it's like a crypto API. It does fully automated key management services and also trust trading. It knows about the message transports, and in the future it will know about the GNUnet thing. Yeah, it does decryption, encryption, and everything. And then the adapter is a language and environment-specific interface between the engine API and an application development environment, which can be a programming language, an IDE, or something. Basically, the adapters are bindings. So this is the list of adapters and example languages. The adapter makes the calls for the function it wants and converts it into a language for the engine. Then the engine magic happens and the result is given back to the adapter and therefore back to the application. So this is the current implementation we have. We have it for various platforms, but the next slide gives this more. It automatically encrypts, it encrypts the subject inline, there's automatic key management, there's import of existing key, There's no key server or any other centralized infrastructure. We have those trust words, which I mentioned before. There's an opt-in passphrase for keys. So by default, there's no passphrase to make it easy. We also have a disclaimer function, meanwhile, which is that weird thing companies do after sending an email, like which breaks all the crypto. Then also a force protection to force everyone to use it, and also passive mode, which is the other way around, to have it off. Also, we encrypt the header and obfuscate as much as possible, and we're working on a sync protocol to have keys synced over various devices. But I go into this in more detail. So this is the applications we have at the moment. There's Outlook, there's Thunderbird for Windows, Linux, and Mac, there's Pap for Android and Pap for iOS, and hopefully more to come because we need to have mass encryption. So now the organizational forms. So we have a foundation, this is where I'm coming from, which supports free software generally, but also the code belongs to the foundation. So this is quite a trick. All the code belongs to the foundation besides the application code, but that's okay. I mean, if you have an application, you want to plug in Pap, the application still belongs to you, but the adapter and the engine belongs to the foundation. So this way we can make sure that whatever happens with whatever investors and all this, that the code still stays free and that the project can still go on. So nothing like some stories we know from the past where projects just broke down because some investors took the wrong decisions. So then we have a company, Pap.security, which is selling applications or plugins and the services. So those guys are taking the investor money and all these things. Also, they get supported by the government of Luxembourg. And yeah, so we are in Switzerland and in Luxembourg for the plain reason because we are Swiss people and we're Luxembourg people. Like at least like one main guy is from Luxembourg and most of the others are from Switzerland. Then we also founded a cooperative for bringing the people together and also for the web plugins, because that's the reality out there. People don't use email clients anymore. They use like webmail, and so we need web plugins. But then web plugins, you cannot sell any investor that you need money for free web plugins, so that's not really possible. So we're trying to do this on a cooperative. Then to bring this all together, we also created some other websites like pap.software, where you can get all the binaries and the code. Then there's Pap Community for the usual community stuff, and there's also supposed to be pap.news, but it's not there yet. But just for the idea to bringing all these entities together, because for a user, like a normal user doesn't care, is this a foundation, is this a company, I don't care. But then for the whole open source world, for the whole crypto world, it's pretty important who is behind it. So yeah. That brings us to the repositories. So the repositories are on different spots, like depending on those different places, especially Enigmail is on SourceForge because it's always been on SourceForge, and it's still like it's a community project. It's still developed by the people who done Enigmail since decades. And we're trying to put everything together on Pap Foundation. I have a screenshot. So that's Pap Foundation. If you click Pap Software, you get this overview. And then if you go on pap.software, you get like an overview of the different applications. This is for Android. And there you also have then the sources and the code audits and all this. It's not fully ready yet, but by the idea. So if you click on reproducible builds, for example, for Outlook, it's not really easy to do that. So we're not so far, but the idea is to provide everything you need to have full transparency. Then this is the list of repos from the foundation. Here, a better readable list, but I go through it faster because I only have 5 minutes left, I've just been told. Also development platforms, so we're developing on everything. It's just quite fun in the dev team, like having the Linux and the BSD guy together, but then also Windows guy and an Android guy. It's always fun. So now the concept, I already said I'm going through this very briefly, so I'm going to be now even more brief and also skipping the GNUnet part, which I then do in the lightning talk tonight. So privacy by default, you already have seen this. It's about automatizing then it shall be easy to understand, easy to use, no training, because nowadays people need training to use email encryption, and then even after training, they still make a lot of mistakes, especially with the key management. So we're trying to have it easy. That's one part of the easy, the trustworthy thing, I already explained that. Another part of the easy is the sync. I explained it rather here. So if you have more than one device, you can sync those devices with each other, you make a handshake, and then you can sync your keys, which is pretty important. At the moment, there is no solution to actually have encrypted emails on various devices, besides using any kind of Apple Cloud or something. And so you can sync your keys, you can also sync contacts and calendar. We're syncing via IMAP. So now the backup problem is solved too. And as we're syncing via IMAP, you're just using not the cloud, but your own computers, because that's like the same thing, right? It's just your own cloud and not others' people's computers. Then we are surely end-to-end, peer-to-peer. We have no centralized infrastructure, nor closed services, which is also very important, always to have the end-to-end thing. And peer-to-peer, no person in the middle. And so generally we're trying to do the things right. PAP is free software, sure. Otherwise it won't work with crypto. Also we're trying to be compatible with multiple crypto technologies, multiple message transports, multiple platforms, multiple languages. I already told us that at the moment we're compatible with all the email encryption which is there, but want to be compatible with some more stuff. Then we're at the moment only understanding email transports, but also want to have the engine speaking other transports as well. And then we have this very important metadata protection, because the content encryption is not everything. Everything else stays visible of an email. Like where does it come from? What's the subject? Okay, subject we can encrypt in line now. But that's very important because encryption doesn't solve the problem per se. The problem with our internet at the moment is that the network just knows and learns too much. I mean, the IP protocol is leaking like crazy. You can spoof addresses, whatever you want. You can listen to everything. We have too much complexity. We have too much centralized components. And so those floors can be misused, and they are misused. So what we need is metadata protection. To explain GNUnet, I usually try it like this. So we have the old internet, where when it started, when people were like, oh great, we can connect computers to each other, I can connect to yours and you can connect to mine, and we can access it and all this. This is great. So nowadays we're like, okay, sure, I can connect to other computers, like servers in the internet, using their services. But then wait, what? They can also access mine. This is how I started every crypto party. If you are connected to the internet is also connected to you. So what we need is to have end-to-end encryption and anonymization of the way data flows. So generally, the summary of the concept, users don't have to think about the crypto anymore. They can just use it by default. Like a journalist wrote once, it's that little hacker inside that decides on the cryptography, choosing to communicate with the message recipient. So the decisions we do daily, like what kind of crypto do we use, what kind of channel do we use, this is what we can do as technologists. But we cannot expect to use, we cannot expect the people out there to make those decisions. So then just a brief note about GNUnet. So I give a lightning talk about it tonight. So it's designed to replace the old internet protocol stack. So they're really rewriting the whole internet. They're doing this since 2002. And meanwhile, it's okay to use it. So we have a full new layered system, but that I'll explain then in the lightning talk. Also, it's now time to check it out, at least as technicians. I think it's going to take like some more years to actually get it deployed for normal people out there. But this will only be in some more years if now technicians are starting to look at this. And then just as a summary, again, we have the right of the protection of the law, I said that the law is not protecting us, so that the law of mathematics is only the one that is protecting us, even though as some politicians don't believe that the law of mathematics is really applying in their country. Laws of mathematics are very commendable, but the only law that applies in Australia is the law of Australia. So there you can see what's the reality out there. This guy is not in charge anymore, fortunately, but just to give you a motivation that mathematics will help us. So then that's about it. Thank you.
Thank you. Questions? Okay.
Hello. Thanks for the good theme. It's really for us quite related. Well, the question is, you have a slide with all the components, engines, and it's like a layered software stack. And what I'm asking about, do you trust the connection between the components of the stack? I mean that it can be easily hijacked, hacked, code injection that can compromise one or two APIs in the stack and thus bring the whole idea of the throughout security down.
Okay.
Or you always trust the system?
You mean somewhere here, I guess. Let me see. Like this or this, right? So this one. Yeah. So this one we need to trust, and we try the very best to trust. So I can assure you our main tech guy, who's also the main person behind this whole project, is a very paranoid person. So no one will ever get hands on the code of the engine who's not fully in a like huge trust bubble of the whole world. So sure, people can submit patches because it's an open source project, but the general developer is like a very trustworthy person. Yeah, but
it's not about source code, it's about runtime. What if in runtime there is a malicious code between adapter and PIP engine that sometimes losing the security, weaken the encryption case, or something made to be done?
Yeah, so I mean that we can just try to assure the same way that we're trying to assure that the adapter code is great as well. But then I know the problem of coming in between. I mean, we cannot really solve that one. There's even one worse problem is on the application side, because then we don't have, like we as Pap don't have any, like we cannot get hands on the application. So the application can even make stuff worse. And then even one more thing, hardware. So in this whole setting, we're trusting the hardware. So all we do is in the user manuals and everywhere we write, do encrypt your device. This is how it works. Please do it, do it, do it. But then we cannot trust all those. I mean, this is for the masses. So people ideally are going to install this on some Windows systems. So the problem is there. And if you have any idea, any process, any thing we can do to avoid it, then we're happy about this. But generally, we do trust hardware, which we shouldn't. And we do trust the environment, which we also shouldn't. So that's why we do need definitely more crypto tools out there which address these problems. So usually, if you want to be really safe, you need to stay in a tails system and all this. But that's if you're gonna, like, if you're a gay person in Bangladesh, or if you're a journalist in, yeah, maybe a journalist in here. But then then you need to do anyway, like lots of more steps. So this is only for the masses. So if there is some injection here, bad luck.
Thank you.
Sorry for not being.
While I'm working for the next question, please, please tell about your materials.
Pardon?
Please tell everyone.
Yeah, I brought those flyers. You also got them in in the badge and stickers, and I have more, so you can pick them up here, and I also dumped them somewhere outside during the day. I don't know where yet, but please take them.
Thank you for your talk. I have actually a question. You talked about public code audits and so on, and about mathematics. Do you perform any, or use, or plan to use any tools to perform formal verification of your protocols and at least of critical parts?
Yeah.
To ensure they are mathematically correct.
Yeah. Like, at least that's the plan. So we're still at the very beginning. At the moment, this whole thing is more or less a proof of concept. So we just came out, you saw the iOS thing is still an alpha. So we're just trying to cover now every platform so that we can choose that, okay, this will work, and then that people can check out the engine. But definitely we want to have automatic checks, as well as we want to have, so the code audit concepts, at least in the concept, says that we have 3 different independent audits all the time. So, and also automatic, like, what's the name? Automatic audits, or, yeah.
The next question.
Hi. Do you have some certification system for plugins, or everybody may write plugin for engine, adapter, of some kind?
That's actually a good question. I'm not sure if the main guys already been thinking about this. What we definitely have is a certification in regards of the use of the name Pap. So if you have an application and then you want to say, okay, I want to plug in Pap there now, like you have whatever, an SMS app, and you want to encrypt it. So then to actually call it then a Pap SMS app, or to call it this app is now having Pap whatever, like in your official name, then there is like trademark issues and la. So I think that could also count somewhat on a certification, because we will only give people the name and the logo if we're sure that they're doing things right. I mean, you can never be 100% sure, but that's how it is with security. It's a process, not a status.
Thank you. So there's the next question from here.
Mm-hmm.
Okay, just a simple question. Since big corporations is not very interested in this security, and even in technical audience, not very much people actually using cryptography. How actually you're supposed to get financing in the long run? So you will have enough base of supporters in the long run.
You're asking about finances, right? Yeah. So the foundation itself has donations on the one hand side, which is mainly the founders who push in money as much as they can. Then we have a few donations, like the usual people donate. And then as a foundation, we also apply to like grants and these things. But then the foundation is just the small piece of the thing. The bigger piece is the company. And the company does get, I mentioned that, like a startup fund for IT startups in Luxembourg. So the government of Luxembourg is funding this. Then there is the usual investor thing. So investors that believe that an email encryption solution will bring money, which I think is not totally bad to believe. Because we've seen it after Snowden, that companies were like, oh my God, we have to do something. And then they're like, okay, we make an evaluation. Oh, 99% of our communication is on email. Oh, great, there is an email encryption solution. So we roll it out. And then they rolled it out and they rolled it back. We have lots of these stories. And we have lots of companies actually just waiting that we finally get the key sync ready, which we already had ready last year. But then there was in testing, we found a bigger flaw, the usual time zone issue. And then we had to like restart it fully. So lots of people are just waiting for the key sync, and then they're going to buy like hundreds and thousands of licenses. So there's definitely a business model. And this is also why we do have this structure of foundation, company, cooperative, so that we do have a company that can follow a business model without destroying the idea of free software. Yeah, thank you.
Thank you, and we have time for the last question.
Yeah, it's actually a semi-political question. Do you already face any fighting from governments? Because let me explain. We had like PGP, off the record, and TAR protocols for years by now, and they're kind of a toy for very selected amount of audience. But what you are trying to do is to make privacy for everyone, and superpowers will always fight this. All of us here in Russia, we know what happened to Telegram, and you know, that's kind of question.
Yeah, that's an important question. I wouldn't say that we already get anything openly. Depending on what paranoia level you're on, you can definitely see lots of attacks we have, or none, depending on the paranoia level. So at the moment, we're still kind of safe because we're still very small. And we're still very at the beginning, and we're also trying to be somewhat still under the radar. So it's not, I think, like if I now climb on this paranoia level, like for those attackers, we're just small fishes, and then we're very freaks, like we're hard freaks. So they're just like, okay, those freaks, they will never make it, and they will run out of money, and like, no worry, this problem is gonna solve by itself. And yeah, the money issue is definitely an issue. Like, we have to run hard, like the usual investor thing, one after another. But I don't, like, from my paranoia level, I don't see any attacks, not at all yet. But we're prepared for it.
Okay, thank you. What is the best question you got?
I think the first or the last, because the last one is very important, but the first one was the best question. So if any, either of you already got the shirt or something, then maybe.
Okay, we can get two. It's no problem. So, and thank you very much for your efforts. Thank you.
Yeah.
We are having a coffee break now.